In this video, we are going to be solving some really important questions from past papers of permutation and combination. Now, what I've done this time, again, I've been doing this for AS level topics and I've done this for admins, and I think I will be doing this from now on because it makes things a whole lot easier, and you kind of get an idea on about the concepts and the kind of questions that you will be that you will get in past papers and in your CIE. So what I've done here is I've basically singled out all the kind of concepts that you will be tested on in past papers, and as I've color coded them. So for example, if you look here, we have arrangements in a straight line, so I've colored this in blue, and what I have next are a handful of past papers, as I said, and I've mentioned that where exactly is this question going to. I mean, I've highlighted the question which deals with this concept in the same color as this. So basically, what I've done is this topic, permutations and combinations, has like 5 or 6 main concepts that the examiner would like to test you on, and once you kind of are able to identify that what this topic is dealing with, then you'll have a better idea, your approach will get better, and inshallah you'll get the hang of this topic also. So let's have a quick look at the topics, at the concepts, sorry, that you will be tested on. So one of them, as I mentioned, is arrangements in a straight line. Okay, in this question, the question be like, so you have 6 objects and you need to arrange all 6 of them in a straight line. How many ways can you do that? So very simple, we'll find out when we come across questions. Then you have like a grand concept, which is arranging R out of n objects. So that means if you have 10, you only need to arrange 4 of them or maybe 3 of them. And this can be further divided, that sometimes the examiner will ask you to arrange them without any restrictions. So you have 10, you just need to arrange 4 of them. Sometimes there will be restrictions, and these usually happen when you're dealing with numbers or you're making chords. So the examiner can say, make sure that the number is even, make sure that the number is odd, make sure that these 2 objects are together, make sure that they're not together, stuff like that. And then there comes conflict situations. Now these questions are like my personal favorite, because I just love to like lay it out and just spread it out and then do it. And that's the kind of method that I would recommend to you guys also. I've noticed that every time students do it with once they've like spread it out, once they've like singled out all the digits, then it just makes things a whole lot easier. Then we talk about selecting objects, and this is basically combinations that we're talking about over here. And again, you'll have without restrictions, and then you'll have with restrictions. For example, these 2 people must be in the same team, and 2 people must not be in the same team, and 2 people must not be separated. And you're probably wondering what's the difference. I'll explain that as we come across a question. Again, these are some really interesting questions. And then you have a condition where it says like this particular object must be included. And then you have questions where you just have to solve without a calculator. For example, you need to work out the value of n, and I solved a question like this. Actually, no, never mind, that was for AS Math. But anyway, questions like these, by the way, you will be tested on. You find questions like these in binomial also. But anyway, that's not what we're dealing with right now. We're dealing with permutations and combinations. So without wasting any more time, let's just get straight. So here's question number 6, part A. This, I should mention, is from October-November 2018, paper 2, variant 2. And this I've highlighted orange or yellow, so which basically means that this deals with selecting objects with restrictions. And as I mentioned earlier, that these kind of questions you can come across when you're dealing with making chords or making numbers, and that's exactly the situation over here. So it says here a 5-character chord is to be formed from all the 13 characters shown below, and you can see that we have 6 letters and 7 numbers. Okay, so I should just put in equals to 6 and equals to 7 so that I know what the total is. Each character may be used only once in any chord, so that's kind of a restriction, that you can only use the chord that you can only use every character only once. Find the number of different chords in which no 2 letters follow each other and no 2 numbers follow each other. So that means it has to be in an alternating sequence. If you have a chord, you got to have a number, and then if you have a letter, then number, and then letter, and then so on and so forth. Or if you're starting with a number, so number, letter, so on and so forth. So how many character chord do we have to make? We have to make a 5-character chord. So 1, 2, 3, 4, and 5. So that means you can start off with a letter, and then you got to have a number, and then a letter again, and then a number, and then a letter again. So how many letters do we have to choose from? We have 6. So that means if 1 out of the 6 is gone, then for the next letter you have 5 options, and then for the next letter you have 4 options, and then as far as the numbers are concerned, you have 7 numbers to choose from. So if one of them is gone, that means you now have 6 to choose from. Or you could have done this like this also. You could have started with a number, and then a letter, and then a number, and then a letter, and then a number. So that means how many numbers do you have to choose from? You have 7 and then 6 and then 5, and then let's talk about the letters. So you have 6 and 5. So let's work this out in our calculator. Of course, 6 into 7 into 5 into 6 into 4 is 5040, or 7 times 6 times 6 times 5 times 5, 7 times, yep, which is equal to 6300. So 5040 or 6300. So let's sum them up and see what we get. So we get 11,700. So that means you can make a total of 11,700 different 5-character codes using these 6 letters and these 7 numbers. Anyway, now we have part B, which says a netball team of 7 players is to be chosen from 10 girls. 3 of these 10 girls are sisters, and this, by the way, I've highlighted gray, which means that you're selecting objects with restrictions. Then it says find the number of different ways the team can be chosen if the team does not contain all 3 sisters. Okay, now it does not say that the team contains none of the 3 sisters. Okay, it says does not contain all 3 sisters. Now I know this may sound very similar, that what exactly is the difference? Now it says does not contain all 3 of them. That means you can have 1 of the 3, you can have 2 of the 3, but you can't have 3 out of 3. Okay, so that means we have a total of 10, right? So let's split this 10. So 7 are normal people who don't have any issues with each other, and the remaining 3 are sisters. I'm just joking. So 7 are people that have no restrictions. These 3 have restrictions. Okay, and how many are you selecting? You're selecting a total of 7. Okay, so one way to do this, to meet this condition, is to just select 2 sisters out of the 3. Now remember, we're selecting here. That means we got to deal with combinations over here. So that means 3C2. Now we had 7 to choose. 2 we've already chosen. That means now we're left with 5 that we're going to choose from, and we have to do that from the remaining 7 people. Okay, because we can't have this one sister again in the pool from which we're selecting people. So that means this has to be 7C5. So let's work this out. So 3C2 times 7C5. So that gives us 63. So remember, this way we have 2 sisters. Okay, now what about when we just have 1 sister? So that means you have 3C1. Okay, let me just write that again. So you have 3C1. Now you've chosen 1 sister. That means you've chosen 1 out of 7 people. You still have 6 to choose from. So 7C6. And let's see what do we get. 3C1 is 3 times 7C6. So that's equal to 21. Okay, now remember, now we have just the 1 sister. Now what about when you have none of the 3? Okay, so that means 3C0, or you can just completely ignore that. Okay, and that means all the 7 people have to come from the other 7 people, excluding the 3 sisters. So that means 7C7, which is basically equal to 1. So summing this up, 1 plus 21 plus 63 gives us, let's find out, 1 plus 21 plus 63 gives us 85, and that is the correct answer. So just to give you a quick summary, whenever the question says none of the 3, that means you just need to exclude all of them. But over here things were slightly different. It said does not contain all 3. Okay, so that means there shouldn't be a scenario where you have all 3 of them, but there can be a scenario where you have 2 out of 3 or 1 out of 3 or none out of 3. Okay, so you got to be able to distinguish. Make sure that you read the question again and again so that you know exactly what you're dealing with, and then attempt the question. All right, now we're dealing with question number 4, which says in an examination candidates must select. So if I were you, I'd definitely highlight or underline the word select 2 questions from the 5 questions in section A, and select 4 questions from the 8 questions in section B. Find the number of different ways this can be done. So this I've highlighted gray, which basically means that this is talking about, hang on, let me just check. So this is talking about selecting objects with restrictions. Okay, so you got to select how many? You got to select 2 out of 5 from section A. So if I have section A over here, so if I have section A over here, so I got to select 2 out of 5, so that means 5C2. And then if I have section B over here, that means I got to select 8 out of 4, so that means 8C4. Now let's work this out and see what do we get. So 5C2, so that's 10 times 8C4, so that's 70, and that's equal to 700, which is the correct answer. And then we come to part B, which says the digits of the number 6378129, so basically 6,378,129 are to be arranged so that the resulting 7-digit number is even. Find the number of ways in which this can be done. So this is arranging R out of, or you can say, we're arranging n out of n objects, but there is a condition, and the condition is that the number should be even. So it's still going to be a 7-digit number, but you got to make sure that this 7-digit number is an even number. So 1, 2, 3, 4, 5, 6, 7. So in order to make sure that the number is even, all you got to worry about what the last digit is. So if the last digit is 2, 4, 6, 8, or 2, 4, 6, 8, or 0, that means the number is definitely going to be an even number. So how many even numbers do you have? You have 6, 8, and 2. So 6, 8, and 2. So that means you have 3 even numbers to choose from. So 3p1 for the last digit. Now we had a total of how many digits? We had a total of 7 digits, and out of the 7, 1 is gone. That means we're left with 6. And how many places do we have? We have a total of 6 places again, so that means 6p6. Now let's work this out, see what do we get. So 6p6 times 3p1. Let's work this out. 6p6 times 3p1. So we have 2160, and that is the correct answer. Okay, this I should mention was from May June 2020, paper 2, variant 1. Okay, then we move on to another question, which is question number 4, and this is from May June 2020, paper 1, variant 2. So let's see what it says. It says find how many different 5-digit numbers can be formed using the digits 1, 2, 3, 5, 7, and 8 if each digit may be used only once in any number. So you have 6 digits to choose from, 6 digits to arrange, and you're making 5-digit numbers. So that means that's going to be a no-brainer, 6p5. And the reason why we're using p is because we're dealing with numbers meaning that the order is important, and the answer is 720. Then it says how many of the numbers found in part 1 are not divisible by 5. So how about we find out the numbers that are divisible by 5 and then subtract it from the total. So if you want to find out the numbers that are divisible by 5, so remember we are making a 5-digit number. In order to make sure that the number is divisible by 5, you got to have 5 as its last digit, which means you just have one available option for the last digit. And we started off with how many numbers? We started off with 6. Now one of them is gone. That means you're left with 5. And how many places do you have? How many places do you have to fill? You have 4. So that means that's going to be 5p4. So 5p4 times 1. Let's see, what do we get? 5p4, which is equal to 120. Now remember, don't get carried away and think this is your final answer. This is not, because what we've done is we've worked out the numbers that are divisible by 5. So if you want the number that aren't divisible by 5, all you got to do is 720 minus 120, which is equal to 600. Okay. Now comes part 3, which I've highlighted yellow. I've been waiting for this question because this is a conflict situation, and these kind of questions are my personal favorite. So it says, how many of the numbers found in part 1 are even and greater than 30,000? Okay, so there are 2 conditions that we need to fulfill. One of them is that they're even, and the other is that they're greater than 30,000. And remember, we have how many digits? We have to make a 5-digit number using 6. So 1, 2, 3, 4, 5. Okay. So I'll tell you why this is a conflict situation. The reason why this is a conflict situation is because let's say we want to make a number even number. So that means we got to have 2 and 8 as its last digit. And if you want to make sure that the number is greater than 30,000, that means you can have 3, 5, 7, and 8 as the first digit. Now, the reason why this becomes a conflict situation is because the number 8 is repeated in the first and the last digit. Okay, so what I like to do with numbers like these, what questions like these, that I like to spread them out. So here's how I'd like to do questions like these. So for the first digit, how many options do we have? Let's say we fix 3 as our first digit. Okay, so that means for the last digit you can have 2 or 8. Okay, now that means for the first place we just have one option because we've fixed 3 ourselves. So that means 1p1 or just 1. And for the last digit we have 2p1. Now, how many digits did we start off with? We started off with 6 digits. 2 of them are gone. So that means now we're left with 4. And we have 3 places to fill. So the way to do that is 4p3. Okay. Or you can break this down and write in 4 into 3 into 2 into 1. Oh, sorry. 4 into 3 into 2. Yeah, not into 1. So 1 into 4 p3 into 2. So that gives us 48. But this is not the end of the question. Okay. So because we just fixed 3, now there could be more possibilities also. So 1, 2, 3, 4, and 5. Now let's say I fix 5 as my first digit. So that means 1, 5. We just have 1, 5. So that's 1. That means again I can fix 2 and 8. So 2p1, and I have 4p3 options for the remaining 3. So that gives me 48 again. Okay, and then 1, 2, 3, 4, and 5. Let's say I fix 7, so that means I can fix 2 and 8 again. So I have 1, and then 2p1, and then 4p3, which is equal to 48 again. And then finally 1, 2, 3, 4, and 5. If I fix 8 as my first digit, so that means I just have one option. And in order to make the number even, I can only fix 2 because 8 isn't available anymore. 8 is now gone, and it's now the first digit. So that means for the last digit also, I just have one available option. And for the remaining 3, how many numbers did I have to choose from? I had 6. 2 of them are gone, so that means 4p3. So 4p3 is equal to 24. Now let's sum it up. Let's sum up the numbers that I'm highlighting: 48, 48, 48. And 24. So 48 plus 48 plus 48 plus 24 plus 24, sorry, is equal to 168. So that means you can make a total of 168 numbers that are greater than 30,000 and also even. Okay, now we're doing part B, which says the number of combinations of n items taken 3 at a time is 6 times the number of combinations of n items taken 2 at a time. Okay, so n items taken 3 at a time basically means NC3. Okay, so you have n, and by the way, this I've highlighted purple, which basically means that this is the question that you have to do without a calculator. I mean, you can use a calculator, but it's really not going to be of much help if you don't know how to work with C without using a calculator. So the number of combinations of n items taken 3 at a time means NC3 is 6 times. That means 6 into the number of combinations of n items taken 2 at a time. So that means NC2. Now NC3 basically is equal to n into n minus 1 into n minus 2 divided by 3 factorial, or simply 3 into 2 into 1, 3 into 2 into 1, which is equal to 6 into n minus 1 upon 2. Now we start cancelling it out. N cancels out with n minus 1 and n minus 1 get cancelled out, and now the 2 and the 2 get cancelled out, so that means you're just looking at n minus 2 is equals to 6, and n minus 2 upon 3 is equals to 6, which means n minus 2 is equals to 18, which means that n is equals to 20, and that, folks, is our final answer. Okay, then we come to another question, which is question number 6, and this is from October-November 2020, paper 2, variant 3. Okay, let's see what it says. So again, it's a number question, and let's see what the difficulty level is like. So it says a 4-digit code is to be formed using 4 different numbers selected from 1, 2, 3, 4, 5, 6, 7, 8, and 9. Find how many different codes can be formed if there are no restrictions. So how many numbers do you have to choose from? You have 9, and you're making a 4-digit code. So since you're making a code, that means you got to use permutations, and 9p4 is the way to do it. So 9p4 is equals to 3024, and that is the correct answer. And then it says only prime numbers are used. So prime numbers are numbers that have only 2 distinct factors, 1 and themselves. So how many prime numbers do we have here? We have 2, 3, 5, and 7. Remember, 9 is not a prime number. 9 is an odd number, but not a prime number. And 1 is also not a prime number. That's a very common error. So if you're using only prime numbers, so how many prime numbers do you have? You have 1, 2, 3, 4, and what's the length of the code? That's also a 4-digit code, so 4p4. So that's the same as 4 factorial. So 4p4 is equal to 24. There you go. 2 even numbers are followed by 2 odd numbers. Okay, so 1, 2, 3, 4. So 1 to 9, how many even numbers do you have? You have 2, 4, 6, and 8. So that's what? 2, 4, 6, 8, 4. And how many odd numbers do you have? So yeah, that means the remaining 5 are odd. So 2 even numbers, so that means you have 4 and 3, because you have 4 even number available for the first place, and then 3 for the second. And then as far as odd numbers are concerned, so that's going to be 5 times 4. So let's work this out. 4 into 3 into 5 into 4. 4 into 3 into 5 into 4. So that's equal to 240, which is the correct answer. Then it says the code forms an even number. So if you want to make sure that the number is an even number, all you got to worry about is what the last digit is. So for the last digit, you can have 2, 4, 6, or 8. So that means you have 4 available options, or you can write this as 4 or 4p1. It means the same thing. Okay. And for the remaining 3, there's nothing to worry about. So that means we started off with 9 numbers. Now we're left with 8. So it's going to be 8p3. So let's work this out. 8p3 times 4. So that means we're looking at 1344, which again is the correct answer. Okay, then it says find the number of ways in which 12 people can be put into 3 groups containing 3, 4, and 5 people respectively. So that means first you're going to put them in groups of 3, and then 4, and then 5. Okay, and you have total of 12 people. So when you're making a group of 3, so that's going to be done 12C3 number of ways. And then remember, 3 people have already been removed from this pool of 12. So that means now you have 9 to choose from, and you're going to put them in a group of 4. So that's 9C4. And then out of the 9, 4 have been removed. So that means you just have 5. So that's going to be 5C5. And there you go. Just work this out. And you'll have the final answer. So 12C3 times 9C4 times 5C5, which is equal to 27,720, which is your final answer. Then it says 4-digit numbers are to be formed using 4 of the digits 2, 3, 7, 8, and 9. Each digit may be used only once in any 4-digit number. Find how many 4-digit numbers can be formed if there are no restrictions. So again, we're starting off with the question. This is usually how the question progresses. First, it asks you how many numbers you can make without any restrictions, and this normally is a 1-mark question. Then it gives you a small condition to worry about, and then it gives you a slightly more complex condition that you gotta, or a restriction that you gotta take into consideration. So how many digits do you have? You have 1, 2, 3, 4, 5. So that means it's gonna be, whoops, sorry about that. Yeah. So that means 5p4. Let's work this out. 5p4. So that's equal to 120, which is the correct answer. And then it says that the number is even. So if you got to make sure that the number is even, you've got to make sure that the last digit is an even number. So that means you can only have 2 or 8 as your last digit, which basically means 2p1. Now, we started off with 5 digits. One of them is gone. So that means only 4 are left, and you have 3 places to fill. So 4p3 times 2p1 is the way to do it. 4p3 times 2p1, which is equal to 48. And that's the correct answer. Okay, again, I've highlighted this yellow, which means that we have a conflict situation. It says the number is greater than 70,000 and odd. Now let's first identify why exactly we have a conflict situation. So if you want to make sure that the number is greater than, I think I said 70,000. I meant 7,000. 7,000 and odd. So you can have 7, 8, or 9 as your first digit. Okay. And then if you want to make sure that it's odd, so you can have 3, 7, and 9 as your last digit. So you can see that there are a couple of numbers that are repeating. So that means that this here is a conflict situation. Okay, and this, by the way, is a name that I like to call it. Okay, it's not like an official name or something. You can't Google it up or something. This is something that, just I like to call it. Okay, so if the number is greater than 70,000, so let's try and place 7 as our first digit, which means we just have one option. And if we've placed 7 and you want to make sure that the number is odd, so we can have 3 and 9 as our last digit. So that means 2p1 or simply 2. And then we had 5 numbers to begin with. Now 2 of them are gone, so that means 3p2. So let's work this out. 3p2 times 2. So 3p2 times 2p1, which is equal to 12. Now we move on, and let's see if we have 8 as our first digit. So that means that's 1, which means we can have 3, 7, or 9 as our last digit, which means we have 3p1 options to choose from. And again, we started off with 5 numbers, 2 of them are gone. So that means we're left with 3, and we have 2 places to fill. So 3p2 times 3p1, which is equal to 18. And then finally, what if we have 9 as our first digit? So that means we just have 1. And then if you want to make sure that the number is odd, so that means now you can only have 3 or 7 as your last digit, which means 2p1. And you had 5 numbers to begin with, 2 of them are gone. That means now you just have 3p2 for the remaining 2 places. So that's 12. So 12 plus 18 plus 12 is equal to 42. And that is the correct answer. So at this point, what I want to do is I will share a PDF of this file. I'll link it, give you guys a link to it in the description box so you guys can download it. But right now, what I want to do is I'm going to skip a few questions, and I want to jump to one question which I really want to solve with you guys. And that's October-November 2019, paper 1, variant 3. And it's part B. The reason why I'm not solving part A is because it's very similar to a question that we just solved. In fact, I think it's exactly the same, or I don't know, maybe you guys find out. Okay, so it says a team of 6 people is to be chosen from 8 men and 14 women. Find the number of different teams that may be chosen if there are no restrictions. So you have 14 people to choose from, and you have 6 to choose. So the way to do that would be 14C6. Now remember, since we're choosing people, okay, so that means we have to use C. So the answer to that is 3003. And there you go, that's your final answer. Then it says there are no women in the team. So if there are no women, that means all of the 6 people have to come from men. So we have 8 men, and we are choosing 6 of them. So 8C6, let's work that out. 8C6 is equals to 28. Okay, now this is an interesting question. It says there are a husband and wife who must not be separated. Okay, so what does that mean? you might think that, okay, that means they must be in the team, okay? And yes, that is correct, but that could also mean that both of them may not be in the team. So, okay, so either they're both in the team or they're both at home chilling or whatever it is that they're doing. So they're both either inside the team or outside the team, okay? So there's no, you can't just have the husband or just have the wife in the team and not the other. So what we're going to do is we're going to break this question down, and we're going to do it two ways. That let's make sure that they are in the team. So if they are in the team, so that means out of the 8 men, we have only 7 to choose from because that husband has to be in the team. And out of the 6 women, we have 5 to choose from because we've already selected that women, okay? So you can think of it this way, that from the 8 men, we have 7 to choose from, and you have how many women to choose from? You have 5 women to choose from, okay? So that means now the total number of people that you have to choose from are 12, and the total number of people that you are selecting is not 6 anymore, because remember, a husband and a wife, they have both been included in the team. So that means now you're just selecting 4. So let's work this out. 12 C4, which is equal to 495. Okay, this is when they are in the team, okay? That they are in the team. Okay, so I'll write it over here so you know exactly what's going on. Now, what if they're both out of the team? So that means we're still choosing 6 people, but if they're both have to be out of the team, so that means now we got to make sure that that one husband is not part of the pool that we're selecting from. So that means now we're going to be selecting from 7, and we got to make sure that that one wife who cannot be in the team is not part of the pool that we're selecting from. So that means we have 5 women to choose from. So that means again we have 12 people to choose from, but this time we're selecting all 6. Okay, we're not selecting 4, because when we were selecting 4, we were under the, we're doing that because both husband and wife are in the team, but this time we're selecting 6 because we have 6 people to choose, because that's what the question says. So 12C6 is equals to 924. So now we just have to sum them up. 495 plus 924 is equal to 1419, and that's the correct answer. This is the way that you can have a husband and a wife who must not be separated. So anyway, I will recommend that you guys download this PDF and solve the remaining questions, or if you have any other topical past papers with you, you can use that. I haven't really made notes of this topic. I will see if I get the time to do that. I will try and make sure I do that. You guys can follow me on Instagram, so that if I do make them, I'll be posting them on my Instagram most likely. So anyway, I'll stop here. That's all for this video. See you guys in the next one. Until then, take care. Bye bye.